Okay, now that we've looked at how to find limits graphically, algebraically, from tables even, it's pretty easy. Let's talk about some of the properties. Well, properties are really easy, seriously. We have the limit of f(x) at a is L, and the limit of g of x as x approaches a is m. So if we had them added together, guess what? We could take the limit as x approaches a of f of x. It's a different color. Plus the limit as x approaches a of g of x. Well, what was the limit for f of x? It was L plus m. Guess what would it be if you subtracted them? It's going to be the limit as x approaches a of f of x minus the limit as x approaches a of g of x. So L minus m. What do you think it would be if we divided them? Same thing. We're going to end up with the limit as x approaches a of f of x divided by the limit as x approaches a of g of x, L over m. What if we multiplied them? Noticing that they're not as scary as we thought. Oh, I didn't change colors. Oh well, you're getting the idea. What if there's a constant in there? C is usually a constant. Well, just factor out the constant. So it'd be C times L. What if we had f of x to some power? Well, just find the limit of f of x and then raise it to that power. What about the limit of a constant? Well, it's just that constant. So how would we use these? Well, let's start with graphically. All right, so we have the limit as x approaches 2 from the left of f of x plus g of x. So the limit as we go to 2 from the left on f of x is 3. And then for g of x, going to 2 from the left is 1. Okay, so limit as x approaches -1 for f of x is -6. It's 2 times that, so 2 times -6 minus 3 times for g of x at -1 is -1. It's really just this easy. As x approaches -3 of f of x, it is -2 minus for g of x is does not exist. So the whole thing does not exist. Why? Well, because the limit as x approaches -3 of g of x is not a real number. I can't subtract a does not exist from a real number. That's silly. Okay, x approaches 6. So for f of x, that's going to be -4. But we have a -2 out here, so that's -2 times -4. And then for g of x at 6 is a +6. That's going to be a +8 over 6, which is 4/3. Two times f of x times g of x as x approaches 4. So we got the 2, f of x, and g of x. Okay, so at 4 on f of x, we're going to -3. And g of x at 4 is 4. And so we're just going to multiply it all together. -24. F of x squared at -2. Okay, so -2 gives me a y value of -5. So -5 squared is 25. Okay, the next one we're going to have to take it bit by bit. It's got g of x as we approach 2 from the right side. So g of x, 2 from the right side, is 6. So that's 2 times 6. And we have the square root, so that's the square root of 2 times 6, which is the square root of 12. Oops. Which is 2√3. 2 from the right, f of x over g of x. Okay, so 2 from the right is -2. And g of x we just found was 6. So -1/3. X approaches -1. F of x minus g of x. So -1 over -6. G of x at -1 was -1. So -6 minus a -1 is -5. Ooh. What if we had to do it analytically? All right, we can do this. So what this is really saying is we're going to plug in. Let's break it down. Okay, so the limit. Let me get up here. Okay, cool. As x approaches 0, 2 times g of x, we need to go ahead and plug in this. G of -2 would be plus 3 times -2 plus 2 over 0. Oh wait, let's not let it go there yet. We're not letting x be 0 yet. We just need to figure out this one, which is -4. Now I'm going to oh, that was, I'm sorry, 2 times 3x plus 2. That works. The limit as x approaches 0 of 6x plus 4. That's negative 6 plus 2. That's a negative 4. That's going to be the limit as x approaches 0 of 6x over x, which is the limit as x approaches 0 of 6, which is just 6. Well, that was so much easier. I like that. Let's try this one. 2x squared minus 3x plus 4. And then it has us plugging in some stuff. So let's be careful here. So we have the limit as h approaches 0 of, if I plug in x plus h, minus 3 times x plus h plus 4. And then I'm going to, I don't know why that parentheses is there, subtract f of x. So 2x squared minus 3x plus 4. All over h. Okay, so limit of 2 times x plus h times x plus h. Hopefully you can see that. Okay, cool. That's x squared plus xh plus xh plus h squared. Well, I'm multiplying by 2, so I'll go ahead and do that. That's 2x squared. That's 2 of those times 2 is 4xh plus 2h squared minus 3x minus 3h plus 4. And then we're going to distribute the negative on these. Minus 2x squared plus 3x minus 4. I am running out of room. Wrote too big at the beginning. Oh my goodness. I bet I can clean some of this up. Let me grab something to help me. I see a plus 4 and a minus 4. I see a positive 3x and a negative 3x. I see a 2x squared and a negative 2x squared. I think that's, let me clean that up. The limit as h approaches 0 of, I have 4xh plus 2h squared minus 3h over h. Ooh, I can divide everything by h. Okay, the limit h approaches 0 of 4x plus 2h minus 3. Now let's plug in 0 for h. That is nifty. That is a neat thing that we're going to be looking at a lot soon. That nifty.